books here. Don't grumble under your breath. I can hear you. Where's the Selena?
Go to
Gotcha.
giraffe level.
Huh?
Giraffe level.
Yeah, okay, you're after that. Last time, huh? You're feeling hot? Take out your clothes. Sit down, take out your clothes and sit down. I have no problem. Take out your clothes and sit down. All of you, look at me, don't look at him. Okay? Just look at me. He's taking off his clothes. Who will not come? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One is that other girl, no? That Tiwari, can see? Yeah. Tiwari, no? No. And the other one is not, she's not come back from a holiday again. She's left to what the class?
She'll come after 7.
After 7, the class, the whole portion is getting over for her. Anyway, have you all finished up your portion till hydrogen? Question and answers at the back of the chapter. How many of you have not done it? Put your hands up. Chapter 1 completely, all the question answers have you finished. All of you, second chapter, first chapter is over. Second chapter, you have finished. You have finished. That boy, show me. Second chapter. You Dhruv, second chapter is finished. I said Dhruv. Since then Dhruv and Satyam sound the same. Huh? Have you finished second chapter? Have you finished second chapter? No. Third chapter? No. Fourth chapter? No. Why? Who will do it for you? You? No. Who have finished second chapter? Third chapter? Show me.
I don't have that.
Very convenient.
I bought the
Very convenient. Again, I say very convenient. You are coming from there and risen from the red. Have you risen from the red? I don't care if you come from heaven or from hell. Why were you not there for so many days?
I was in the concourse selection.
What?
Selection.
Oh. Who selected you for what? You are playing with the football or they have converted you into a football? Huh? Are you playing football or have they converted you into a football? You're not answering my question.
I was playing.
So then how many 12 are there? 1, 2, 3, 4, 5, 11. No, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 is that girl, and 12 is the other girl, no? There are 12. There are 12 in the class, not 11. Okay? I want to, after I finish up this particular paragraph, which I'm going to explain to you, I want to check up your work and see what you have not done and what you have done. Those who have not done their homework and not completed it, I will throw you out of the classroom. I've already signed. That girl has signed. You, all of you have signed. You stay very close by, no?
No,
There. Very convenient. You wrong book you bring. Suddenly you stay very, very far away.
suddenly I actually lived there.
And then so therefore, because you are so far away, you deliberately didn't bring you got chemistry, the physics book for chemistry. You pass it on to that boy. That footballer. Now, who's going to complete all your previous work? Whole of start section you have missed out. And so many other topics you missed out. How you do it? I wonder whether half the time the video was off. Half the time it was off. Anyway, now we come to close all your books and pay attention. We come to study of gas laws. So if I say study of gas laws, which part of matter are we talking about? I am pointing out to one person. If anybody opens his mouth or her mouth, I'll lock it up. Are you cockeyed? Are you? Neither am I. Which part of matter are we talking about?
Yes.
Only gas. Only gas. Now, if we are talking about only gas, only gases, okay? Now, each and every one of you has to give me a general property of gas. I don't say, Miss, that's the same thing I wanted to say. Miss, that I will not tolerate. I come and slap you. And the same slap I give to the other person who was giving me the same answer. So think of a different property of a gas. Yes. What property? General.
We have the least intermolecular force of
We
attraction.
have least intermolecular force of attraction. So least, okay. Least intermolecular force of attraction. Okay, 1 point is up. Okay. Now, I'm going to give you a question. If they have got the least intermolecular force of attraction, what is the result? What will be the result? What will be the consequence of that? What will be the consequence if the intermolecular force of attraction is weak?
They can take the shape of the container or
That is one point. Yeah.
they will have intermolecular spaces. They will have
So that's what he said. Least. Yes, what you said
intermolecular spaces.
is large.
Yeah.
It has multiple spaces. So yes, thank you. Very good. Second one will be large intermolecular spaces. Correct. Second point over. Third point.
Goodness.
The
kinetic energy is maximum.
wrong. Not only wrong. Bullshit. You know what? The shit coming out from the bull, I can make use of because I'm a farmer. I use it as manure. But what is coming out from your mouth, I can't use at all. So useless is what you have spoken just now. You're an intelligent you are an intelligent girl. Coming out from you is disgraceful. You want to bury me alive? Oh, send me to an early grave, not early grave, late grave. I'm already old. Foolish fool. You, if you put that hand up and break that hand of yours, put it down. Yeah.
Kinetic energy is the least.
Kinetic energy is the least. Okay. Kinetic energy is least. Why is it least? Why is it least? Okay. Give me another point. This is also a debatable point. You're another one like her. I put it on the point on the board, but I haven't accepted that point. Yeah. It is low, but there's something you have to say, which you're not saying.
Gases can flow.
Gases can.
Flow.
Why?
Because they have a lot of intermolecular space.
And because of these two
They can
points.
move easily.
Because of these 2 points. Correct?
Uh,
So they. Then, as per the boy, red t-shirt. Anything about a gas? It takes.
Shape of the container.
Okay, it takes the shape of the container in which they put. Why?
Because of less intermolecular space.
Okay, because.
Intermolecular space and less intermolecular.
Okay, because of these two again, the first 2 points. In the third one, take. One can say. Then what? Number 6. Something like this only, but then further talking about the container.
are highly diffusible.
Highly diffusible. Okay. Highly diffusible. What's the meaning of diffusible? Highly diffusible. It's really the alarm has my shoe. Highly diffusible means what?
Can whatever was easy.
No. Diffusible means what? Highly diffusible. Diffusible means what? Say.
Easy.
Means what? Diffusible means what?
Close screen.
No. Fluidity is fluidity. Diffusible means what? Skull. Diffusible means what?
And it can flow in all the directions.
No. Diffusible. Who knows the meaning of diffusible? Yeah.
It can diffuse with the molecule.
Don't use the same word.
It can mix with other
Mix. Diffusible means mix. Intermixing. Diffusible means intermixing. Okay? Highly diffusible. Now, why are they highly diffusible? Why are they highly diffusible? Why is it that the gaseous molecule of one gas diffuses or is highly mixable with the molecules of another gas? Why?
Less kinetic energy and less molecular.
Because of the kinetic energy and because of the intermolecular spacious space between the molecules. Correct? Next one.
Gases have mass.
Gases have
Mass.
mass. Okay, they have mass. Number 7. Mass. They have mass. What else? Last boy.
They don't have definite volume.
They don't have a definite volume. Okay, so what is their volume then? What is their volume then? What will be their volume?
The volume of the container.
Closed container.
Closed.
Because the volume of the closed container is here contained. No definite volume. Number 8. No definite volume. Okay? Volume is of the closed container containing them. Okay? Then also I can give you some more. Means they are highly compressible. Why? Again, because of the intermolecular spaces between their molecules. Highly compressible. And they're highly expandable. Because of the heat, they can keep on expanding. Why can they be expanding because of the heat?
because of the intermolecular because of the intermolecular of attraction. Or
What happens?
spaces.
No. Why? Why?
Because kinetic energy increases with heat.
Kinetic energy is directly proportional to temperature. I'm talking about why is it when you give them the temperature, they can expand very easily. Why?
Because
Why?
Because the molecules go far away from each other.
Why they go far away from each other?
Kinetic energy is more.
No. Why is it that the molecular forces of attraction increase?
because they can their bonds are weak.
Because
and
the
they can-
intermolecular force of attraction is weak. So therefore the temperature breaks it. And the bond is broken. And they're free to move in any and every direction. Okay? So these are the general properties of gases. General properties. So you know all of them there. So these are all the general properties of gases. Now, all these gases are governed by 3 values or 3 constants. Okay? What do I mean by saying that they are governed by 3 constants? Okay? They are governed by the 3 constants. That means they are governed by 3 constants. 3 constants. Their behavior is governed by 3 constants. Volume, which is V, temperature, which is T, and pressure, P, which is P. These are the fixed constants. Now, what happens to these constants? So, if, first of all, I use the word gases, and I gave you the properties of gases. When I use the word gases, what idea did you get about all these properties regarding gases? Okay, yeah.
They are fluid.
No. What I mean by saying is my question is not very clear. But what I'm trying to say is that was I speaking about any particular gas? So these are the properties of all the gases. So all gases behave in the same manner under the same conditions of temperature and pressure. Okay? And their volume also. So this is the general properties of all the gases. No specific gas. All gases behave in the same manner under the same conditions of temperature and pressure. Now, if I keep the volume of a particular gas, of all the gases, hydrogen and nitrogen and chlorine and bromine and all the gases, if I keep their volume 100 ml, if I keep their temperature at, say, for instance, 273 degrees, and I keep their pressure at 1 atmospheric pressure, all of them will behave the same. But if I change one of these constants, immediately you find that the behavior is changing depending upon whose constant I changed. Okay? If I change the temperature of one gas, you'll find all the other gases behaving in one manner, but that one gas whose temperature has changed is behaving differently. So the behavioral pattern of gases will be controlled by these three constants: volume, temperature, and pressure. Otherwise, all gases are in a state of random motion. They're in the state of random motion, meaning they are moving anywhere, and they are in a closed container. Okay, so therefore they occupy the full space of that container. Their shape belongs to the shape of that container. Okay, is that clear, all of you? Now, if I change the temperature, immediately I will find that the motion will increase. The motion will increase. Why is the motion increasing? Because when I'm doing that temperature is a form of energy. What happens to you when you eat your food in the afternoon and you have extra energy? Do you keep on moving up and down? Are you sitting quietly? No, you're sitting quietly because you're hungry and you're hungry and you're hungry. Your energy is very low. But the moment you get your food to eat and your energy in your body is built up, do you sit quietly? No, you are trying to sit everywhere, even on my head. It's the same thing with the gases, gaseous molecules. They will all be in random motion and their motion will increase. If I decrease the temperature, if I'm decreasing the temperature, what I'm doing? Taking away the energy. Correct? When you take away the energy, they will become weak. They will not move up and down. They move slowly and slowly and slowly. And then I'm not only taking out the temperature, I'm not only taking away the energy, but I'm also increasing pressure. So what am I doing? I'm bringing them closer and closer to each other. I am compressing them. And when they are compressing them, I'm bringing them so close to each other that the intermolecular force of attraction is becoming stronger. Correct? And then they're becoming closer to each other. As the force of attraction is increasing, they're coming closer to closer. And when they come very close together, they're forming liquids. Okay, this is general behavior, all right, of gases and gaseous molecules. Okay? Now, these gases are these gaseous molecules, but they're in a particular thing. They're continuously moving. Now, the pressure in that thing is actually calculated on the amount of force they exert on one unit area of the tin. Meaning what? Suppose this is the tin. Okay? And the gaseous molecules are at random motion. They're hitting each other and they're hitting the walls of the container. And they're building up the pressure. How do I calculate the pressure? I will calculate the pressure depending upon how much of force the gaseous molecules are exerting on this unit area of the container. How much of force the gaseous molecules are hitting or exerting on that one unit area of the container. When I know that, calculate how much of force they are putting on that one unit area, I can multiply the total area and find out the overall pressure. That's the way I calculate. This is clear? Now, so therefore, because these are variables They're constants, but they keep on varying depending upon which gaseous law I am using. There are three gaseous laws. One is the Boyle's law, one is Charles' law, and one is the general gas law. These are the three different gas laws that govern the behavior of a gas when it is in a closed container. Now, in the case of Boyle's law, what is kept constant is temperature. Temperature, if you read the problem and you see the word temperature is kept constant, that means you have to use only Boyle's law. If you are reading and they say that pressure is kept constant, then you have to use Charles' law. And if they have not mentioned what is constant, then you have to use the general gas equation. No mention of any constants. No mention of any constant. When they have not said the temperature is kept constant. When they have not, that means temperature is mentioned to you. They have not said volume is constant. That means volume is mentioned to you. They have not mentioned that pressure is constant. That means pressure is mentioned to you. Okay? Therefore, you have to use the general gas equation. Now, what is the Boyle's law? So, let us talk about the very first law. Am I going too fast? Okay, till there you read. All of you till there you read. Then I will start with Boyle's law. Till there you read. All of you read from here. Till there you read. Till there you read. Then I talk about this. Till there you read. Hurry up. All of you read from there. Okay, not that. Why my hands and my this thing is so straight and yours is slanting? You're drunk or what when you're writing? This is the work handwriting of a drunkard. कुछ किया है क्या जब तो आपको लिखता है ये सब? हाँ? पीकर लिखता है क्या? फिर सीधा लिखने को क्या होता है आपको? हाँ? खड़ा, खड़ा, खड़ा. When you are giving anybody a pen, open it up like this, put it like this, and give this end, not this end. This end hurts the person. You give it this way. Thank you. Okay, please. सिर्फ पेजेस को फिलअप करने का है क्या पूरा? You don't have any other work to do? Now, because these one thing you have forgotten is that kinetic energy is very low, you have to use that word that the density of the gases is very low. Density of the gas is very low because very few particles are there. All these few particles occupy the full capacity of that container. You have to say the density of the gases are very low, hence the kinetic energy is low. Yeah, what happened? No, see what happened is no. Basically, temperature will be kept constant, pressure will be kept constant, and then they'll say that find out the volume. Some unknown will be there. Usually the volume is unknown. Okay? Follow? then when you find out the volume, you ultimately find the volume of both the gases, because it's always comparison between two gases. When I explain to you boils down, you will understand what I'm trying to say. Right now, just remember this. One of them will be, if they say volume is kept constant, pressure is kept constant, then you find out the temperature. One unknown will be asked, okay?
When we were doing this on building, he was waiting for the next.
Who you saw? Who you have seen now? Takat.
She was waiting for our bus.
Bus.
After like in the bus stand.
She didn't the bus so far outside. Where did she stay?
I don't know, like she was waiting like near sector 14. Near sector 14.
And where do you stay?
Sector 29. We were coming the auto rickshaw.
So you can picture up, na? You can picture up or not?
She was really far. Like we were in
We
the third day. We were in the third day of the road, and she was like in the bus.
Next time when you see like that, then you should pick up the person and bring them. That is an act of charity you've done. Remember that every opportunity you get to do one act, always make it a point to do one good act per day. Every day you get up in the morning and say, today I have to do one good act per day. Whether it's to my mother, to my father, to my brother, to my teacher, Mrs. Logo, to anybody. Then you feel satisfied. I've done my duty for the day. One act of goodness, kindness. That you should always remember. Make it a point to do it.
This is also a point. Gases exert pressure and overlapping shapes.
Yeah, that's what I said. The exert pressure, but you find out the force pressure is the force that is exerted in one unit area and then multiply the entire area and find the total pressure. What is pressure of a gas? Pressure is nothing else but the force of a gas that is exerted per unit area on the walls of the container.
Should I read this part also? Yes.
Gas or alcohol. Children, if you have got the Dalal, please make it a point to read Selena. Because Selena will give you good explanation. And the children who have got 99 and 100 and 100 and 100 have always said, ma'am, we use Selena. Even though in our school we use Dalal, but at home we used Selena. I didn't mention the definition. Right now, the answer. Right now, the answer. Right now, just read.
saw an experiment where they took an aluminum tin and they put some water in it and they boiled, and after some time they put cold water in it.
Yeah. Then what has happened is they take a tin, okay, and they so much of water. Above is all air.
And they heat it up.
Ah,
And
heat.
with the closed.
Yeah. No, open. Yeah, little open, always open. So what has happened now? All that air this is boiling. So the boiling means all the air is being escaping. Then what happens? They close it. They stop yeah. Now what happens is even if they don't put water, there is less pressure inside when compared to atmospheric pressure. So atmospheric pressure is exerting pressure on the walls of the container and it has pressure. Okay. If I want it to be very, very quick, I put cold water. I shrunk the water molecule and therefore it has, because the pressure inside become very less. Because the pressure inside your body and the pressure outside the body is equal. Okay, you are full. Not you don't collapse. Because the pressure outside is much more. You don't need so much. Follow? As you are born, your body gets accustomed to the atmospheric pressure. So therefore you don't catch as a baby. You are still entire. So I think your brain must have frozen, I think your genes must have frozen. Sometimes you don't think correctly, that's why. And he doesn't think at all, full stop. Huh?
It is the reason why we are in the space. Astronauts wear suits because they enter the space.
Yes. As a manner in a zigzag manner, not straight this way. In any straight line, in any direction. No disciplined direction. Haphazard means not disciplined direction. Any direction. But straight line, no curving. No curvy lines. Straight lines.
Plus 200 and it's 305 degrees Kelvin.
Huh?
305 degrees Kelvin.
305 degrees Kelvin is what?
Temperature.
Whose temperature?
Mumbai.
Who asked you to find the temperature of Mumbai? Huh? Who asked you? You're a thermometer Bombay or what? Kazan? Idiotic idiot. Do you what?
305 degrees Kelvin.
It's not 305 degree, it's like 305 Kelvin.
Kelvin, there's no degree. It becomes only in centigrade.
Centigrade or
Or Fahrenheit.
100 in
It's
Fahrenheit.
cool.
Formula?
That I will tell you, you first read what is it called? Chunk.
And minus 32 upon. There is 78 going input.
Come on, read carefully with concentration. I'm going to ask you questions on what you have read.
I'm thinking
Can I read? Or the big one?
Like I know what this is.
क्योंकि सवाल करना जरूरी है.
Exactly.
You think I have not gone to school? Was I? I learned Hindi, I learned Marathi, I learned French, I learned German and Portuguese. If you're finished reading, put your hands up, ask me if you have any difficulty in understanding any paragraph, I'll explain to you. I didn't come at 11 o'clock today. 11 o'clock today. Why should
Marathi.
so early should be Manisha? Anybody want? Which subject supposed to? Which inter. Have you finished reading? Yes or no? You're not saying yes, you're not saying no, I just can't understand. Therefore, what I can't understand. Now pay attention, you go to the next part. So first of all, now when we're talking about the three constants, we spoke about volume, we spoke about temperature, and we spoke about pressures. We've got to use IS standard, meaning international standards. Okay, when you're using these constants, you've got to use standards. The standard for the volume is either 1 liter, which is equal to what now? 1000 milliliters, correct? Or it is equal to 1000 centimeter cube. Centimeter cube or cubic centimeters. Decimeter cube or cubic decimeter. So this is the standard that you have to use. If you're talking about temperature, we have got your degree, we've got your degree centigrade, or we've got the Kelvin scale. We've got the Kelvin scale. Okay? And we don't use Fahrenheit. We use only centigrade or the Kelvin scale. Now, if I want to convert, if in the problem they have used the Kelvin scale, all right, in one particular case, and in another case, they have used the centigrade scale, then you have to convert the centigrade scale to Kelvin scale. And how will you do it? How will you do it? Kelvin scale is equal to centigrade scale plus 273 real. That is how you convert the centigrade scale to Kelvin scale. Okay? That is the word that you have to remember that. And finally, when it comes to pressure, pressure will always be, say, 1 atmospheric pressure or 30 Pascal. Don't touch Pascal, don't touch Torricellian, scale. Only normal atmospheric scale, which is, say, 76 what? 76 centimeter. Okay? Or we have got 760 millimeters atmospheric pressure. Either 76 centimeters of mercury or 760 millimeters of the mercury column. Nothing else. Don't confuse. Now, we know pretty well that as we increase the temperature, the movement of the gaseous molecules keep on increasing. And as we take away the temperature, decrease the temperature, we are decreasing the movement of the molecules of gases, gaseous molecules. And we decrease, and we decrease, and we decrease, and the motion of the gaseous molecules become less and less and less and less until we come to absolute zero. We come to absolute zero, absolute zero, absolute zero Kelvin, absolute zero Kelvin, which is equal to minus 273 degrees centigrade. Absolute zero. So if you're talking about centigrade scale, we're decreasing till we come to zero, then minus 1, minus 2, minus 273. At that time, we find that there is no motion in the gaseous molecule. There's still difficult to reach this temperature. It's an arbitrary scale, but it is there. And why did we stop at minus 273 degrees? Because at that time, there is no movement at all in the gaseous molecule. Otherwise, there is slight movement, slight. And the movement keeps on decreasing as the temperature is decreasing. But at minus 273 degrees centigrade, there is no movement at all. That minus 273 degrees centigrade is equivalent to 0 Kelvin. Is this clear? So what is absolute zero? Absolute zero is equivalent to minus 273 degrees centigrade. That is the scale. What is so special about the scale? Is at that time that there is absolute no movement in any molecule of the gaseous sample that we are testing. Okay? Now, we come to Boyle's law. The first law is Boyle's law. Now, what does Boyle's law state? Boyle's law states that the pressure of a gas varies inversely as its volume. Pressure of a gas varies inversely as its volume when the temperature is kept constant. That means what? We have to take a closed container. Suppose we take a closed container like this. Okay? And this is filled with a gas. This has got a piston rod. Tight fitting piston rod. Now what is happening is, as we push the rod down, what are we doing? We are decreasing the volume. And when we decrease the volume, what's happening? We are bringing the molecules of the gas closer. So that gas is becoming more and more dense. Okay? And the pressure inside the gas is increasing. Because the movement is there. Correct? And you're decreasing the capacity for it to move. If you increase the capacity, it will move and the pressure will decrease depending upon the space. But here you are bringing the piston down, you're decreasing the volume, and that's how the pressure is increasing. Why? Because they're bringing the molecules of the gas very, very close to each other, and therefore the gas is becoming more and more dense. And with the density of the gas increasing, the pressure is also increasing. So therefore, we have got Boyle's law states that pressure of a gas is inversely proportional to its volume. When temperature is kept constant. When temperature is kept constant. Temperature is kept constant. So whether you increase it, you increase the volume and decrease the pressure, temperature is the same. When you increase the volume and decrease the when you decrease the volume and increase the pressure, temperature is the same. Your Boyle's law is effective in a closed container. The container has to be airtight. So therefore they say P is pressure, it varies inversely as volume. Am I right? Look at pressure varies inversely as volume. Now let us work it out. The pressure varies inversely as volume. Now what we will do is, we have here pressure varies inversely as volume, temperature kept constant. Okay, we don't say temperature, T kept constant. Then you have got there cross multiply. PV varies as 1. Am I right? Have you got that much correct? Okay, so we've got there PV is equal to K, where K is a constant. K is a constant. Correct? Is this clear? So therefore, what we have now, P1V1 is equal to P2V2 is equal to P3V3 is equal to constant. What is P1V1? P1V1 is the pressure and volume of one gas. P2V2 is the pressure and volume of a second gas. P3V3 is the pressure and volume of the third gas. So when 3-4 gases, usually you don't have 3-4 gases, 2 gases are put together. When 2 gases are put together and the pressure is given to you, the volume is given to you, correct? Oh, the pressure is given to you, you have to calculate the volume. That problem we will do. So this is, have all of you understood Boyle's law? Remember, when temperature is kept constant, this you have to remember. This you have to remember. How to derive it, you know how to derive it. But when you remember, this is to be remembered. Boyle's law, P1V1 is equal to P2V2. If it's Charles' law, P1V1, T1 is equal to P2V2 as a different formula altogether. Remember the formulae depending upon what is kept constant. Temperature kept constant, P1V1 is equal to P2V2. Pressure is kept constant, P1V1 upon T1 is equal to P2V2, where because pressure is kept constant. You have to learn these formulae by heart. And if you general gas pressure, P1V1 upon T1 is equal to P2, that's a different gas law altogether. Check and see what they have asked you in the problem, and accordingly you will work it out. Is this clear? Now, in the case of a balloon, you are blowing a balloon. Okay? When you blow a balloon, alright, you are putting the air in the fixed volume, meaning the fixed in the closed balloon. Okay? Is Boyle's law applicable to the balloon when you're blowing the balloon? Is Boyle's law applicable? Will pressure vary inversely as volume? Yes? Anyone? Huh? No, why?
Because when we blow in more air, so it like increases the volume and pressure increases.
See, first of all, when you're blowing in a balloon, volume is increasing because the balloon is not in an airtight container, the volume is expanding, the volume has to be fixed. It is to be an airtight container, airtight. The capacity of the container should not increase. Here you are blowing, the mass is increasing, the pressure is increasing, and the volume of the balloon also is increasing. Here is the volume increasing, the volume is fixed. 100 ml I have taken. And at 100 ml I am working the experiment. 100 ml, okay, and that is the volume, and the pressure is what I am applying on that closed container. Is the container expanding? No, the container is fixed. The case of the balloon, the skin is expanding. You're blowing and you're blowing and you're blowing more and more air. Is the volume of air fixed? No. You're continuously blowing in. You're adding more and more mass of air. And with that, the pressure is also increasing. This is clear. The pressure is decreasing, sorry. The pressure is decreasing because the balloon is expanding. The balloon is expanding. So those variables are not fixed. You cannot apply Boyle's law to the inflation of a balloon. Okay, because the capacity of the balloon is not fixed, the volume is not fixed because the skin is expanding. You are continuously increasing the quantity of gas, and as the volume is expanding, the pressure is decreasing. Clear, all of you? So now you read Boyle's law only, and then I would like you to read the problems that are worked out there. Do you want me to work out a problem on the board? Yes or no? I will work out the problem on the board, not to worry. You read the Boyle's law. Do not bother about graphical representation of Boyle's law. That is not in your course. That's not in your course. You only learn the derivation of Boyle's law and the problems. I will work out a problem on the board, and then subsequent problems from Bilal, from Serena, you have to work out on your own. Read. Tomorrow is English. No?
Yeah. I guess it's from 2:45 to 6, right?
Again in the afternoon? No, I want to come in the morning. I don't want to go in the afternoon. I want to come in the morning.
In the timetable, it is like 2:45
to
or
6.
No.
Like there is no class before that.
So you'll have to come in directly at 2:45.
It was 7:30 to 10.
Huh?
It was 7:30 to 10:45.
7:30 to 10:45. Just now open at that time. 8:30 they have to go home and do their work in my home. Morning I have to sit and do the work in the morning. Take early in the morning. No, I can't come in the morning.
So you will come at 2:45.
What the time is 2:35.
Shall I show you?
No, that's
So,
No, I know it is there, but tomorrow Saturday, no? Okay. Tomorrow Saturday, so 2:45. This quarter to 3.
2:45.
So quarter to 3 to quarter to 4 to 4:15. And 4:30 to 5:30 to 6 o'clock. That's okay, come in the afternoon. I'm not very good. And so what to do tomorrow then?
And tomorrow, on Julius.
Julius Caesar, I finished
Actual ma'am, no ma'am, not half.
Half of
Not
it.
Julius Caesar
No,
ma'am.
no, I have to do 1 hour Julius Caesar I've got to do. I'm going to do 1 hour Julius Caesar and 1 hour I'll do what now?
Essay writing. Essay is done.
Essay writing I'll do that time now.
Oh no, you did now.
Yes. You like something from treasure chest.
From
Treasure chest.
one moment. Read.
Let's do modern millionaires.
Huh?
Modern
Modern
millionaires.
The boy who broke the bank.
Wait.
Other is supposed to tell the boy who broke the bank. Other branches have done it.
Other branches have done it. Which other branches?
It's showing on the tests.
Like
Hard
it
work.
shows in Avyas, like it is
Hard work,
done.
hard work. Hard work.
Okay, 1 moment. This is okay. Julius Caesar 2 hours are left. No. So I'll do 1 hour on Julius Caesar and the boy who broke the bank. The boy who broke the bank. Tomorrow. Give me the pen. The boy who broke the bank. Is tomorrow what is it?
Yeah.
Yeah. So tomorrow Julius Caesar and the boy who broke the bank. Bring your Julius Caesar, bring treasure trove and bring volume.
Treasure chest.
Treasure chest.
I also like say treasure trove because my
Because
brother.
older
Yeah.
ones have got treasure trove.
My brother studied from treasure trove.
He's in which class, my brother?
Now he's in second year.
Yeah. So I got a treasure trove. I got that treasure trove. Now treasure chest. Come on, read. Have you finished reading? Satyat, I come and smash your brains open, okay? But see how much of brain has still there in your head. I find it very difficult. It will be like looking out for a needle in a haystack. That will be the difficulty. Searching for your brains in that skull of yours.
Read inside looks like.
Eh. Only have to do it now. While the idiot opening his mouth, they are for another idiot.
The edges.
Have you finished? Have you finished? see now we'll do there are two some type of motherboard, two different types, okay? Did you all do Boyle's law last year?
No, ma'am.
Now pay attention here.
I don't think so.
Okay, so now this is the problem. A gas occupies 800 centimeter cube under 760 ml pressure. Find under what pressure the gas will occupy 380 centimeter cube. The pressure remaining constant. Now that one, what law will be used? Don't tell him, let him say. What law will be used here? Easy, yeah. Hurry up, don't waste my time. What law will be used here? Hurry up. Do you know? You, what law will be used here? What? Just tell me the name, don't give me the law. Why? Where have you put your Boyle? Where is the word inversely proportional? So how do you know you're using Boyle's law here? How do you know you're using Boyle's law here? Why do you say Boyle's law? Why are you using Boyle's law here? Huh? What happened? No. So who told you that? What law will you use here? Yeah? Yeah, so temperature is constant. So when temperature is constant, the Boyle's law to be used, I said. No? I told you, no? When temperature is constant, Boyle's law to be used, yes or no? Why did you not? Temperature is kept constant, see that Boyle's isn't talking. Did you hear what I said just now? What did I say? What did I say? All of you were talking. What did I say just now?
That in Boyle's law, temperature is kept constant.
So then,
So here is temperature is kept constant, that's why it's Boyle's law.
that's why we have to use Boyle's law. Temperature is kept constant. And I told you that if temperature is kept constant, you have to use Boyle's law. Did I not tell you that or not? Give him one knock on his head. He doesn't want to pay attention. You go home. You go home. Now, what is Boyle's law? What is Boyle's law? P1 is equal to P2 is equal to a constant. So we don't want to all this. P1 is equal to P2. Now, what is P1? Look at the very first one. P1, pressure 1, P1, V1. And then you have P2 and V2. Like here. Under occupies, this is the volume, 800. So first volume is 800. What is the pressure? 760 ml. Correct? First pressure is here. Occupies volume, 800. Pressure, 760. Find under what pressure. The second pressure you don't know. The gas will occupy 380 centimeter cubed. Got it now? How you fill up the information? V1, V1, V2, V2. Now you understood? Who hasn't understood this? How to fill up? Now you will do it. How will you do it now? P1, V1 is equal to P2, V2. So we have got your P1 is what now? 760. P1,
760
P1 into 800. 800 is equal to P2 is what? P2 you don't know. And V2 is what? 380. So how will
We
you?
have to write
It's centimeter.
No,
it's
divided by 380 that.
That I know.
To write the units.
No, just leave it. This is just calculations. So therefore now we find out P2. Therefore P2 is equal to 760 into 800 upon 380.
0, 0.
So we can cut out what will become 40 and this becomes 90.
38 is I'm 38 is
And
that.
I
Okay.
will go with 760.
Like 38 is 76.
And that is 800.
That
80
is 80 only. 800 is that is 80 only above 800.
Correct? So we can calculate. Is it okay? That is what P2 is 1600. So pressure is what now?
P2 is equal to
P2 is equal to 1600 atmospheric pressure. Cubic, what will be the pressure now? We have got 60 mm. No? This is the answer. Is this clear? Have you followed now? Who hasn't understood this? Raise your hands. All of you followed? Let me do the sums in your book. Every sum. I will do another one. We'll do another one. Now pay attention to the second one.